Yeah, good afternoon, sir. Sorry, good evening, sir. Yeah, good evening, sir. Yeah.
Hello. Mansa, are you there?
Yes, sir.
Oh, you have started?
Yes, sir. Please
Oh,
proceed.
great. Okay,
Thank you.
thank you. Thank you. Sorry about the delay, guys. Got a little late coming home. Got stuck in the middle and things like that in traffic and things like that, guys. My apologies. Also, apologies on Friday I couldn't take due to some emergency meeting and things like that, guys. And my apologies again. So, just want to make sure everybody can hear me fine. Could you give me a quick yes, guys? Could you please type in the chat window? Can everybody hear me? Great, thank you, guys. So let's continue our journey. I think we were discussing about the clustering algorithm, and we looked at a case study involving clustering. Oh, I think, okay, so just a quick and a friendly review. Clustering is about forming the groups and the centroids, and if you recall, within the groups, they're very similar to each other. All the points, all the pink color points are very similar to each other. The pink color points are very dissimilar to the brown, the red, and the green. In other words, between the groups, the similarities are less or the dissimilarities are more. And within a group, imagine all the pinks are the cats. They're all similar to each other. We can say all the cats are similar to each other, but the cats are dissimilar to the dogs. And we discussed about how the process of the stage of convergence comes in and how it stops at a certain point. Then I think we went ahead and looked at our case study, which is where we looked at the mall customers data. I'm gonna run this one up to here. Give it a moment. I'm just waiting. Okay. Then I think we did some visualizations, guys. I'm gonna skip some of them which I covered, but I want to just go ahead and show you the last one, which is this one. So this is where we are able to understand the characteristics of different customers. So put this here. So if you recall, all the light blue colors, these are the customers where their annual income, where their income is less and spending is less. And if you take a look at the pink colors, their income is more but their spending is less. The dark blue ones are the ones where the income is somewhere in the middle, which we can say is average, and the spending score is also in the middle, so their spending is also average. The reds is where the spending is more but the income is less, and the greens is where the income is more and the spending is also more. So based on this, we are able to understand the characteristics. We are able to understand that somebody is a very sensible. Who are the group of customers who are sensible? Who are careful customers, standard customers, careless customers, and target customers, guys. This is where we were. This is where ideally we would sit with business and we would this kind of um, groups. Based on this kind of groups, we can go ahead and name this group of customers as the careful versus the careless versus the target customers. And the target customers will be the most important thing from a business standpoint, guys. Okay, so let's extend this one. What we have done is we have formed 5 groups here, guys. What ideally in a real world, what we would do is we would use a method called elbow curve. So let's see. I'm gonna, instead of manually hard coding. So in other words, what we have done is when we created an object of k-means, we hard coded 5. But ideally in a real world, we will go ahead and follow a process here. K-means clusters, visualizing the clusters. necessary customers. Okay. Just copy this one. Just move a little bit and try to put here. Beautiful customers, samples, and it's here. Sorry guys, I didn't get a chance to share this one, but today I'll definitely share once the end of the session. So don't worry about it, guys. Okay. So now I'm going to first, I'm going to try to run the code here first, and then I will explain you what is in the code, guys. Okay. So I'll start with an empty list, a simple for loop that will print the numbers from 1 to 10. If you remember, the mantra is inclusive versus exclusive. For sake of simplicity or discipline, I'll run 2 to 11 that prints numbers 2 to 10. Then come back here. For the sake of simplicity, we'll say 1, but ideally 1 is not really necessary. But first, let me run the code, and then I'll try to explain this to you. This is where the main action is going on, and let's see what we have here. Let's go copy this one here, this here, and now let's see what's happening here, guys. In a real world, many times what happens is whether we should form 4 groups or 4 clusters, 5 groups or 5 clusters is something which we are hard coding. Sometimes the business gives us an indication, but many times the business may not have an indication also. On y-axis, what we have is Wcss. It stands for within cluster sum of squares. What it means is, if we come back here, put this here, and I guess I will need to come back here one more time, snap this one, put this back. What is within cluster sum of squares? This is called a cluster or group, which the clustering algorithm has formed. From the cluster to from the centroid, the yellow one is the centroid, the center of that cluster, to every point within that cluster, you calculate the distance d1, d2, d3, d4, and what you do, you square it and you sum it. That is called, and so in other words, all the distances, you square them and you sum them. That is called within cluster sum of squares. You repeat that for this group, you repeat for this group, and you repeat for this group, the third group, and the fourth group, guys. Now you add all of them. What is that? That is what is on within cluster sum of squares, which is this one. It's what we are plotting on y-axis within WCSS. Now, let's say, come back here one more time, snap this one. What this is suggesting is, when you start with 2 clusters, your within cluster sum of squares is coming this much, that is close to that number. Then 3 is coming to be that much, that is close to that one. At 4 it is that much, roughly. At 5 it is that much. Roughly at about 6, 5 and 6, it's almost very close to each other. There is not a lot of difference. So roughly we can say the optimal number of clusters can be taken as 5 or 6. Since this looks like an elbow, we call that as an elbow curve. Okay, what is this? This is more of a performance or an optimization technique to find the optimal number of clusters, slightly advanced technique, guys. Okay, I will not go too much into it, but just a quick touch of how you come up with the clusters is what this one. Ideally, you can come up with 3, 4, 5. You will make your interpretation. You will try to come up with your understanding and insightful suggestions and things like that. That's what you will do. But here is an optimal way, guys. So that is a little bit about clustering, guys. Let me come back here. So gentlemen, ladies, I don't expect you to understand that perfectly, but if you got a slight idea, that is good enough, guys. As long as you're able to connect to the clustering algorithm, that is a more important word. Okay, more important thing. Okay, guys. Quick yes, guys. Okay. So let's say today I want to introduce you to another algorithm. So I come back here. It is a very useful one in real world. It's referred as association rules mining. And let's see what that means, guys. Okay. So here's what we have. In data mining is slightly like an old-fashioned term for machine learning. And we were performing machine learning techniques on small amounts of data, on databases and data warehouses. That is data mining, guys. Okay. So association rule mining is a popular and a well-researched method for discovering interesting relations between the variables in large data. Okay. To understand what is interesting relation, to be more precise, imagine a group of people there's a supermarket, and imagine a group of people are going to a supermarket. Okay, let's say here is a supermarket, and let's say a group of people, let's say this is a group of people are getting into supermarket. One more time, I'm gonna slip this, I'm gonna move this. A group of people are entering the supermarket, and let's say here is a shelf. Here is a shelf on. Let's say here is another shelf. And in this shelf, let's assume, choose this one. Here is a packet of bread. Imagine someone from this group of customers went ahead and picked up bread. Customers who purchase bread, what may they end up buying, guys? Generally, customers who purchase bread, what else might they buy? Can you take a quick guess, guys? Butter, jam, milk, and things like that. That is pretty logical. That's a pretty logical thing. Is it interesting? Well, it is okay. It is insightful. It is good to know, but it is a simple thing. Interesting, but a simple thing. But here is what is happening. What is association rules mining doing? It's finding what is called interesting relations. What is interesting relations? Let's say, come back here, choose this one. Imagine here is diapers. Okay. Now what is happening is customers. Can you take a guess? What do customers who purchase diapers may purchase, guys? Let's see your answers here. What do you think customers? If customers who are purchasing bread are purchasing butter, jam, and milk, okay. Baby products, okay, simple answer. That's a logical thing, okay. But here is what is happening. Customers who are purchasing diapers are purchasing beer. Okay, what is that? That is what association rules mining finds. That is what it finds them. It calls them as interesting relations, guys. Okay, in other words, that is, if you ask me, a super interesting relation. Customers who are purchasing diapers are purchasing beer. What is that one? That is something which as humans, we can never logically understand that connection of things like that. But what is the history behind it? That is what one of the popular supermarkets ended up finding. It seems that they took all their 10 years of data and they started performing association rules mining. Something interesting which came up is, in USA, during Friday afternoons or Friday evenings, a lot of white males, American males, when they go out for shopping, during evenings especially, whenever they were purchasing diapers, what did they find? They ended up buying beer. So what did this pattern was looking super interesting, so they conducted a survey. They called a lot of people and they asked them, we observed that when you purchased the diaper, you went and purchased beer. Why did you purchase and how did you purchase beer is one of their questions they asked. So what they told was, most of them on Friday evenings, people were going home early because it was Friday evening. And when they go home, these were all probably married and maybe they have babies, single child, or maybe children at their home. So their wife asked them to go to the supermarket and asked them to bring the diapers. And they go to the supermarket, they're picking up the diapers. The culture there is, during Friday evenings, Friday nights, they watch the games, just like our IPL games and things like that. And when they were picking up the diapers, they would recall it's a game night. Okay, so their culture is they'll call a few friends, have a pizza, have a beer, and watch the game, have some fun and things like that. What's that? That is how, whenever on Friday evenings they were picking up the diapers, they ended up purchasing the beer. Everybody with me, guys? Can you give me a guess? Are you catching that? Beer for checking the quality of the diapers. Okay, guys. So let's see. That is, to be more precise, that is called super interesting. If you were to ask me, that's a super interesting relation is generally what I call that. It's not just an interesting. It is intended to identify strong rules discovered in databases using different measures of interest. That is what is the mathematics behind it. We'll try to understand that. The rule found in the sales data of a supermarket would indicate if a customer buys onions and potatoes together, he or she is also likely to buy hamburger meat. So in other words, when customers, another interesting thing is when they were buying onions and potatoes, we'll say they were buying the burgers is what they will treat. We'll ignore this word and just for the sake of discipline and things like that, guys. Okay. Such information can be used as the basis for decisions about marketing activities such as promotional pricing or product placements. Okay, in other words, what that means is if you know whenever customers are purchasing diapers, they are purchasing beer, what you can do is you can probably put the diapers and the beer together. Okay, what is that? That is called product placement strategy. If you go to large supermarkets, what will be they're constantly doing on a daily basis? They are adjusting. They're putting some products here, and things like that. They're changing the placement of the different products and things like that, guys. Okay. And another one is if you know the diapers or beers are being purchased together, maybe you can come up with some discount. If you buy diapers, there is a discount on beer, or maybe vice versa and things like that. What is that? That is called promotional pricing. Okay, association rules mining is used for things like that, guys. So here is some input data. Let's say this is the input data. This is how it looks like. This is the input to the association rules mining. Ideally, transaction ID 1. These are all the things which are purchased by a customer. He purchased citrus fruit, semi-finished bread, margarine, ready soups, tropical fruit. These are the These are the transactions purchased by a customer. Another customer purchased these things. That's transaction ID 2. Another customer purchased only whole milk. Another one purchased these, and another one purchased these two. That is what is going on, guys. Okay. So ideally, this is how the input data for association rules mining would look like, and this is the output that we get. Association rules mining is indicating when customers are purchasing cheese, they're purchasing milk. When they're purchasing milk, they're also purchasing cheese. So what is it? They give what is called a support. What is support? Support is 0.01, which means for every 100 transactions, they are observing that 1 out of 100 transactions, 0.01 is 1 by 100. For every 100 transactions, at least one time a combination. When the cheese is being purchased, the milk is also being purchased, is being observed. This is something like a probability. Support is like a probability. The actual number of occurrences by the total number of occurrences, guys. Then comes confidence. What is confidence? Confidence is conditional probability. Simple way to understand conditional probabilities. Imagine there is a cricket match tomorrow. Let's say we are playing with Australia, and let's say India's chances of winning the game is 60%. But by evening, you come to know that Virat is not playing because he's injured. Now what happens? Well, your chances of winning the game is only 50-50. From 60-40, it has reduced to 50-50. Why? Because Virat is not going to play is what you came to know. What is that? That's a condition. So based on a condition, the probability is going to fluctuate. It can decrease or it can also increase. What is that? That is called conditional probability. You add more conditions, the probability can fluctuate. In other words, if a customer has selected or added hard cheese to his cart, okay, what is the probability that they will purchase milk? Well, that is what is confidence. If this condition is satisfied, what is the probability that this may be selected or added to the cart is what is conditional probability, guys. Okay, so and then comes lift. Lift is 1.6. Lift is influence. There is a influence of the left hand side on the right hand side. At a logical level, we call that as an influence. We can also call that as a correlation. Sometimes, for some reason, a combination of two items are going together. Whenever customers purchase a lot of sliced cheese, they're going for milk. Or whenever they're purchasing berries, they are buying a lot of yogurt. We don't know. Imagine they are not related. But still they're going. What is that? In such cases, generally, the lift is very high. If the lift is high, there is a lot of influence of the left-hand side on the right-hand side is one way to think of it, or one way to understand it, guys, okay? If you dig a little bit deep, take a look at this. The concept is same, but the data is different. Apply the same concept to movies. So customers who are watching Strawberry Blonde are watching Canterville Ghost. Support is 6.9%. So what that means is for every 100 transactions we're observing, 100 transactions or 100 records, we're observing 6 out of 100, we're observing this pattern happening a lot. Confidence is close to 35%, which means if somebody watches Strawberry Blonde, there is a 35% probability that they will also watch Canterville Ghost. Okay, what is that? Based on this condition, what is the probability that they may go for Canterville Ghost is conditional probability. And again, as the lift is more, the influence of the left-hand side is more on the right-hand side. Or in other words, that is the correlation. There's a lot of correlation. These two are going together a lot is what it means. Now notice here, everything is one-to-one. One movie to one movie, one movie to one movie. What you can do, this is called single cardinality. You can, an association rules mining will also give you what is called multiple cardinality. So come here, take a look at this. Customers who are watching Green Slime and Jack the Ripper are also watching She. Okay, this is a 3% means 3 out of 100 transactions contain this pattern. If somebody watches these two, there is a 75% probability that they're also going to watching the movie She. And the lift is high. In real world, you may get a higher lift and things like that, which means the more the lift, the more the combination is appearing. What is this? Here, 2 of them are giving you 1. Whenever they watch these two, what are they watching? Like that, an association rules mining will give you lots and lots of cardinalities. If you have a lot of data, it will take a very, very long time to run this algorithm, guys. This is multiple cardinalities, guys. Now, if we go one step deep, and let's try to understand the mathematics behind it. Here's what is going on. Support. So constraints on below measures are used to select useful and best rules of all the rules given by R or Python. After analyzing these values for all the rules, best rules for the basket have been obtained. In other words, these are called constraints. And what's happening? Support. Proportion of the transaction in the dataset which contain the interest. So support is X union Y. Number of transactions involving Jack the Ripper and Strawberry Blonde divided by total. In other words, this is the actual number of transactions. This is the total number of transactions. That is a simple definition of probability. Now here is conditional probability, which is number of transactions where Strawberry Blonde was also bought when Jack the Ripper was bought. So here is Jack the Ripper. Customers who are watching Jack the Ripper are also watching Strawberry Blonde. That's what we are trying to understand. When Jack the Ripper was bought or when they watched that movie, how many times have they watched Strawberry Blonde? Based on this condition, what we are doing is we are calculating the probability that is referred as conditional probability, that is called confidence. Lift is at a mathematical level, it's a ratio of observed support to the expected support. I myself struggle to simplify this a little bit, guys, but it's kind of a, that is what it is. X union Y, we are picking up the numerator from here, and we're taking the support of X, which is the probability of X divided by and the probability of Y. That is how the formula looks like, guys. Okay, so I myself struggle a little bit to interpret the lift, but a short way to remember is it is indicating the influence or it is indicating the correlation is what it means, guys. All right, and so let's say in a real world, what happens is when we are using association rules mining, we generally start with the minimum support. Minimum support is applied means, imagine we are understanding, our insight is that whenever customers are purchasing diapers, they are also purchasing beer. How many times is this happening? How many times is this pattern happening? The business may be interested in all those kind of rules. We call these as rules, which are happening maybe 7 out of 10 times, 10 out of 10 times, 20 out of 10 times, or 50 out of 100 and 100 times. Okay, more precisely, 5 out of 10, 7 out of 10. So what is that? That is the minimum support. You will probably understand that when I actually show you the code and give you an example. That is generally where we start. We'll say, hey, I want all those rules which are satisfying this minimum support. These are referred as the item sets, guys. Okay. So let's get into a little bit of action and try to see if we can simplify and understand this a bit more. So come here. There it is. So all the way up here. Stop the sharing for one moment here. Open this one. Let me see if I'm sharing it one more time. So share it. And give it a moment. I'm trying to open a large Excel file, which is our data. There it is, guys. If you look at this all the way down, if you go all the way down, it looks like it contains 536,000 rows, 36,000 rows roughly. And if you start here, this is invoice number. Zoom it up a little bit. You touch it, it will take a little long time, guys. So there it is, invoice number. So take a look at this guy. These are all the products. These are all belonging to one transaction. They all have the same invoice number, which means one customer. He purchased these things. We have about 500,000 of these things. So this guy on a particular day, invoice date 12/1. That's probably December 1st, 2010. Up to here or here. What did this guy purchase? Well, this guy, 6 up to here. This guy purchased white hanging heart light holder, white metal lantern, cream cupid hearts coat hanger, and so on. Okay, so from here to here, these were the things ordered by this guy. And what do we have? Well, he ordered, how many of them? What's the quantity? What's the date he ordered? And what else we have? We have the date. This is the unit price. Each one, how much is the price? And here is the customer ID, the ID of that customer. That means they belong to one customer. This guy is from United Kingdom. If you select the country column, let's go to data. Let's see if we can filter it. If you look here, this online retail dataset contains these many countries. Close to 20 or 30 countries is what we have. That's what it is. So a lot of countries are ordering the products from this particular retail business, guys. Okay, I'll close it just to save some memory and things like that. That's a quick look at our data. Now let's get back into a little bit of action, guys. Let's see what we have. Okay, so for this one, we will need to run something called ML extend as a package. By default, scikit-learn does not have association rules mining algorithm inbuilt into it, guys. You can install PIP if you're in. I'm sorry, I think I'm showing you Spider here. I'll get back to a little bit of Jupyter here. Let's say come back here and see if I can find that one. Start the sharing. And let's see where we are. It's my WhatsApp, 9 AM. And I'm going to say file, new, notebook. I'll share this again. Sorry about that. Share this one. Come back here. There it is, Jupyter Notebook. So for me, I have already installed Spider, so I don't need to run this one, guys. I've already installed Jupyter, Anaconda, and things like that. Spider is another one. So for now, for the sake of discipline, I'll copy it from here instead of the notepad, guys. So let's copy this one. Here are some imports. I'm going to import them. Wait a moment. Pandas, if you recall, is the package for data frame. ML extend is one. PIP install is nothing but these are packages. When you say PIP install, it's going to connect to internet. It's going to download, connect to a server, and it's going to download all the functions related to that particular algorithm, guys. All right. So these are some of the imports. Then let's come here. So here is online retail. This will take a little bit of time because it's 500,000 rows. It take a little bit of time, guys. Few seconds. Let's run it. While this is running, what we are doing OS, it provides some utility functions. It tells you currently we're pointing to this directory. Then I'm asking my Jupyter to change the directory to our data sets, which is this one. Then this is where we are reading it. Notice the star, because there are 500,000 rows, it's still running. It's taking some time to process it. It's loading up all the data into the memory of the RAM, and it's going to, it is taking some time. Yes, as simple as that. Then data.head will give you the top 5 rows. So let's give it a moment just to verify while that is coming up here. Please type in your questions while we are waiting for this step to complete, guys, if you have any questions. And still processing, guys. 500,000, it should take about half a minute to minute, maybe 2 minutes and things like that. In real world, when you're dealing with big data and things like that, we can also use PySpark. PySpark is nothing but Python on top of Spark. So if you learn Python machine learning and things like that, PySpark is almost similar. Although the conceptually it is a lot similar. Just the class names and everything will be slightly different, guys. Okay, that is generally what you will end up doing. We'll use the Python scikit-learn along with that. We'll also end up doing the PySpark part of it, guys, in real world. So you just want to keep it in mind. MLExtend is a package name, guys. Just like Pandas is a package for data frames, and NumPy is a package for arrays and matrices. MLExtend is a package for one algorithm, which is association rules mining. It's also called as market basket analysis. PIP is used to connect to the server. Yes, PIP will, when you run PIP install, what will happen is it will actually connect to the server. It will download the functions and the files related to that particular package. Okay. The data structures we are using is the NumPy arrays, the pandas, data frames, the classes. These are some of the data structures. We don't use advanced data structures such as trees, B trees, and things like that, guys. It's not really. I'll do it tonight, Sri. Sorry about that. Once this is done, I'll promise you. I'll do that. So there it is, guys. Invoice number, stock code, description, white hanging, heart, light holder, quantity, invoice date, unit price. This is the top 5 rows. If you move towards a little bit right hand side, that's the country and the customer ID. So we loaded the data. Now let's play around with it. Come here. What we are going to be doing is, you said data.columns. This will give you a list of all the columns, invoice number and things like that. Now we'll do a little bit of pre-processing. Take a look at this, guys. What we are doing is alist.str. What this will do is alist.str means you're taking each column, you're converting it to a string, you're doing a strip. Strip means you're removing. If at all there are any unnecessary spaces in the left hand side or the right hand side, it will remove them. You're just making it neat and clean, as simple as that. Invoice number will just be invoice number without any spaces. Next, again, generally a common discipline is you convert all the column names into lowercase. So just in case invoice number is repeated 2 times, you know that if it is lowercase, then you can catch it easily. And if at all there are any spaces, replace them with a hyphen. So fortunately here we don't have any spaces. There's nothing wrong in it. If there's a space, you are replacing it with hyphen. Replace as the name suggests, guys. Then come here, replace any left brackets, just in case. If there are any left brackets or right brackets, replace it with an empty string and an empty string. As simple as that, guys. Cool. Then come back here. There is a head. And verifying. So again, so that is how the original data looks like. Even though it looks like I just modified it, I did not modify it. Why? What we'll now do is take a look at this one. Data.columns. I'm going to run this one. And just to explain you each step, I have run them separately. Now if I say data.head, notice invoice number, everything is converted to small lowercase. If at all there were any special characters and things like that, you can replace them with empty string. So here we didn't have any spaces, we didn't have any brackets and things like that, so that we have clean. The data columns have been pretty clean here, but in case you find some special characters and things like that, feel free to remove them. That is a touch of a data pre-processing step, guys. Then come back here. Let's see what else we have. Info, if you recall, info will give you the metadata. It will tell you each column, hey, there are 541,000 rows, totally 8 columns. Object means that is textual data. Date and time, that is just date and time. So pandas is automatically detecting the date and the time here. Then that is the float, which is nothing but numeric data, and the country is the textual data. It looks like it is taking 33 MB in our RAM. That is what it is info. We call that as metadata, guys. These are some of the basics I have covered. Then we are going to see the dimensions. That's about 541,000 rows, close to 8 columns. Shape will give you the dimension. Then we'll see how many unique invoices are there. So if I run this, 25,900, which means 25,900 transactions roughly. N unique. You're saying data.invoice means the column. You're asking how many of them are unique. N unique means number of unique, that is 25,900 invoices or kind of roughly transactions. Count of customer IDs. How many customers place this one? Okay, a customer can place multiple orders. It's close to 4,000 customers who played close to 25,000. That means roughly, imagine for sake of simplicity, I'll put it like this. One customer has been putting close to 40 orders. 4,000 multiplied by, 4,000 multiplied by 6. Each customer. 4 times 6 is 24. That gets close to 24,000 or 25,000. Everybody with me so far, guys? Can you give me a quick yes? Okay, we can also do describe, but let's stick to this and see what we are going to be doing. So now we'll say here is the value counts. What are we doing? We are looking at the invoice number. This invoice number. So let's say a particular customer, this guy came in, and what did he do? He placed about 1,114 item. He placed an order of 1,114. This invoice number is repeated, is appearing 1,114 times. Value count, each value. What is the value? Invoice number, how many times it's appearing, that is the count. So this, on this guy, whoever this guy, he placed 1,000. This guy placed 700. So that's a very pretty large retail store is what is the meaning of it, guys. Then come here, length of data, that should give you number of rows, 541,000, guys. Let me see. Okay, good. Then let's see. So drop invoice number. Will not drop it right now. I probably don't need it. So take a look at this guy. For sake of discipline, what I'm going to do is data.info. So let's say comment this one. That's not data.info. One more time. We'll check the metadata. Let's see what is invoice number. Invoice number is an object. Okay, let me just convert it to string. I don't know if it's going to successfully convert it. From what I recall, I had some issue here, but let's see. Okay, it still says it's an object, even though it's an str. So ideally, I'm trying to convert this one to a string. It should, I expected it should say a string, but will not worry about it, guys. Not a very, very important thing. Just in case something is a integer or something is textual data, you want to explicitly convert it to a string. That is what it is. Invoice numbers, they are generally, these are like I01, I02 and things like that. So I think I'm explicitly trying to convert it. But again, not very, very important, guys. Okay. But let's say, take a look at this, guys. Here is another big one here. Data. We're going to the data frame, data. We're using a filter. We're saying, give me all the invoice numbers which do not contain C. What is do not? Take a look at this tilde. So from here, the filter is saying data.invoice string contains C. If each invoice, it's going to the invoice column, it's looking at each column. If it is containing C, and then what are you saying? You're putting a tilde. It means pick up all invoices which do not contain, which are not starting with the C. We have total of 540,000 invoices, out of which 532,000 do not contain C. C means they are consumer. Consumer means you and me. Okay, if it does not contain C, that means these orders are coming from the business. Imagine our retail organization, we are getting some orders from the business, some orders from the consumers. Consumers is people like us. We're only interested in business users, not the consumers, because generally the business users take the majority. We want to focus more on the business because they are the greater percentage and they are contribute more and things like that. Imagine that is one of the business rule. So now come back here, say data.country.unique. When you say data of country, you're accessing a column. These are all the countries from where orders are being placed in our retail organization. If you say unique, if you say length, that gives you about 38 countries around the world are ordering from this particular retail store. Now take a look at this, guys. And I'm going to increase the complexity. I'm going to use some complex filtering, and let's see if we can simplify it here. So here is basket. What we are doing is we're going to take all the rows, all the records of Australia, take all the orders from Australia, group by invoice number, description, and here is quantity. Okay, let's see how this looks like. When you filter this, you'll get a data frame. It will be slightly confusing, but let's see. Okay. This basket. This is the invoice number. We see something called 6. We don't know what is invoice number, what is description. This is a group by operation. We're doing a quantity. This is slightly half complete. In other words, this is not really complete. We don't see an invoice number, we don't see a description, and it looks like we're only seeing a quantity here. So what happened to invoice number and description? Well, ideally, the right way to do this is, generally when we perform a group by operation, what we do is we give an aggregation operation. Let me move this a little bit here. So take a look at this. You would take all the Australian orders, group by invoice number and description, take the quantity and sum it. You can do a sum, you can do an average, mean, median, and things like that. So let's say come here. Now if you do this one, take a look at this. Here's what is. It's taking each invoice number and it's putting in this invoice number, this guy ordered alarm clock green, alarm clock red, black blue umbrella, blue dyno wall clock. And what is happening? It's taking the quantity and summing it. This guy ordered 4 of them. In our Excel spreadsheet, this is probably, maybe it's appearing as 4 records, or maybe 2 records, or maybe 3 1 records, and things like that. So it's taking all the quantity and summing it. Okay, so if you're looking at this group by operation for the first time, it may be slightly confusing, but stick with me, guys. Okay, that's what we generally do. You try to understand each invoice, how many times, what is the quantity of this and the sum. Instead of sum, you can give mean, median, mode, and things like that also. Now let's extend this. Take a look at this. We will take the quantity. At the end, what we are doing is we are doing an unstack. So if you do unstack, notice what is happening is whatever is invoice number, the invoice number has become the row index. If you look here, invoice number is also row index here. The invoice number is more instead of 0, 1, 2, 3, 4, you're seeing the invoice numbers here. And then whatever is the description, what is this one? What's happening is all the descriptions, the unique values have become the columns. What is that? That's what the unstack is doing. Unstack is kind of like transposing the rows into columns. But when it transposes the rows into columns, what's it doing, guys? It is taking the second part of it, which is description. It's creating unique column names. So what does this mean? This guy, whoever this guy is, he did not order Dolly Girl Beaker. But if you move towards right hand side, notice this guy, whoever this guy is, he ordered 24 of these things, which is Dolly Pegs Retro Sport. And if you move here, this invoice contains, he ordered 24 Retro Sports, whatever that is. I will try to have a look at that, guys. Everybody with me, guys? Are you all following me? Can you give me a quick yes? Okay, so now let's dig a little bit deep into it, guys. That is what unstack is doing. One more time, let's come back here. If we say basket.shape, that should give us the rows and columns. This will contain only 57 rows and 608 columns. Now, again, one more time, basket.head, it should give us the top 5 rows and columns. So about top 5 rows, 600 columns is what it has been transformed into. Next, what we'll do, we'll unstack it and we'll say reset index. In other words, take a look at this. It looks like invoice number is acting like an index here. Now, if you say reset index, repeating this process, we'll reset index. Okay. So notice the invoice number has become a column and the index has become 0, 1, 2, 3, 4. That's like index. Okay. Next, what we'll do, we'll see a lot of NAs. NAs is corrupted data or null values, like null values and things like that, guys. What is this one? We cannot use this kind of null values for machine learning. Machine learning algorithms don't understand null values. So what we'll do is, we'll say fill NA. We'll use a function called fill NA and we'll put a 0. So what that is going to do is, it's going to go to each cell. So here, what the data frame is doing is, wherever there is a null value, it's kind of putting up a 0. Okay, so if you look here, wherever there are actual, if it is not a null value, it leaves it as it is. So here, most of them will be zeros. That is because a customer or an invoice may not contain everything. It will contain only specific things, is what it is, guys. Okay, so what is fill NA doing? Fill NA is wherever it's finding an NA is like a null value, it's filling up a 0. Okay, guys. Now, one more time, let's go ahead and verify the shape of it. 57 rows, 600 columns roughly. And here is a function called Encode. So let's say, run this one. It's a simple function, but it may look a little bit complex, guys. What it is going to do is, it's going to take a value. It's checking if it is less than 0 or equal to 0, it is going to return 0. If it is greater than or equal to 1, it will return 1. Okay, now, before I'm going to execute this one, take a look at this one. Here is the second invoice ID. Let's move towards right hand side. If you notice, this guy is 24. Okay, what is this one? This is 20 dolly pegs retro sport. This, in this invoice, some guy ordered about 24 of these items, guys. So now what we'll do is a slightly advanced function in data frames, apply map. Okay, so for now I'll not go too much deep. I'll give you a high level explanation of apply map, and we'll pass in that function. And let's say copy this one. We'll run this one. Let's do. So now take a look at this. What is happening is, when you say apply map and you give this function, the data frame is going to pick up each cell. If it is less than or equal to 0, it will leave it as 0. If it comes across any number which is greater than 0, okay, if it is greater than or equal to 1, it is going to convert that into 1. So if you look here now, after we ran this one, notice there is a 1. So it's going to go to every cell. What is that? That's what apply map does. It will take a function, it is applying to every cell. Everybody with me, guys. Quick yes, please. Okay, now come down here, scroll down here, 2 rows, 600 columns. That's just the top 2 is what we are looking at. Now take a look at this column called postage. If you run this one, here is the postage column. One of the columns is postage. Postage 0 means maybe it is land. Maybe somebody from Australia ordered some items via land. Some are in an emergency. Maybe they needed more urgent, so they ordered by flight. Some maybe by ship and things like that. The objective of association rules mining algorithm is, we want to understand when customers are purchasing diapers, what they are purchasing. How they have ordered may not be very, very important. Okay, whether they could have ordered on land, air, or maybe shipping. So what do we have? Well, if we count the columns now, length will give us the columns. We have 608 columns. What we are going to do is, we are going to drop the postage column because it is unimportant. In other words, because we are not interested in the postage, we'll remove the postage, so it reduces to 607 columns. Still a lot of columns. And one more time, now we're going to use a class called transaction encoder, which is part of the ML extend package. A priori and association rules are also part of this package, guys. We're going to import them. And this is where a little bit of action begins, guys. Now take a look at this. Frequent item sets. First, I'm going to run this one. Frequent item sets, and this is how it looks like. What we are doing is, support we have given as 0.07. This is generally the minimum support. Imagine somebody in this retail store is telling they're interested in all those patterns which are happening 7 out of 100. Every time 100 transactions are happening, what are all the patterns of items which are appearing at least 7 times out of 100? What is that? That becomes our minimum support equals to 0.07. When we run an association rules algorithm, we give our data. This is the minimum support we generally start with. You may be interested in 0.07, 0.08, or that could be 0.7, 0.8, whatever it is. You start somewhere. You can start somewhere. And what's this? This is what is happening. So let's say print frequent item set. So 0.07 retro spot. So what's happening is, I wish I can adjust this one in a more printable format. Say come here. Okay, so what is happening is support is 0.07. What this is, let me try to explain it like this, guys. Okay, 36 pencil tube retro spot. What this is telling is, this is appearing 7 out of 100 times. For every 100 transactions, you're observing only 36 pencil tube retro spot. What is that? That is not really useful. Generally, what is useful is, this is like only one. Take a look at this one. This is also appearing 7 every time. For every 100 transactions, we're observing whenever customers purchase this lunchbox, they're also purchasing circus parade lunchbox. This is happening 7 out of 100 times. And what's happening? Whenever they're purchasing a cake stand, they're also purchasing girl lunchbox. So what is this one? This is multiple cardinality. So what is happening? We have our a priori has generated. When we have given the data, it has generated 189 rules like this. This will be a data frame. We can filter out. Imagine there's a retail store manager. He's interested in only the lunch boxes. So what can you do? This is a data frame. You can just write a filter. Give me only the lunchbox rules. What can you do? That will further reduce to maybe 10 or 20 rules and things like that. And then we can spend some time. And ideally, a retail business guy would try to look at this and will try to understand whenever customers are purchasing lunchbox, what are they ordering? They're also ordering another lunchbox. They're also ordering maybe whatever that circus. All these are lunchboxes. Or let's say they're ordering the cake stands. Okay. Now, for us, when somebody orders a lunchbox, will they order the cake stand or not? We may not be able to precisely understand the logic behind it, guys. Take a look at this one. Here is Dolly lunchbox. What is it? It looks like this. This is the lunchbox. When the customers are ordering this lunchbox, what are they ordering? They are also ordering, let's say, Regency cake stand, 3 type. Copy this. And the thing, this is the cake stand they also seem to be. Now we may not necessarily understand, but the business people who are into this one may get feel, okay, why they are ordering a lunchbox and this one together. Okay, they will have their own reasoning. And what can they do? Okay, it looks like these things are happening 7 out of 100 times. Maybe imagine that is a lot higher. What will happen? Well, why not we put them together? Or maybe we're giving a lot of discounts on these things. Let's stop them because people are used to it buying this now, these two together. What is this? This is some of the insights that we can generate out of this one. Everybody catching the point, guys? Can you give me a quick yes, please? This is exactly how they found out that when customers were purchasing diapers, they were purchasing beer. And here, what can we do? We are just talking about 2 items, guys. But in real world, you can spend a whole lot of time. That is what you'll do as data scientist. That is what you'll do as AI professional. That is what is expected of you. You now go to the business and tell them, guys, these are some of the patterns which are happening. But in real world, what happens, guys? 189 is a big number. What you need to do is, you can give us a slightly different number. You play around. If you give 180, if you go with 189 rules, and you sit in front of your business, you try to explain 180 rules, that will take a very, very long time. You try to adjust this number, make it 7, make it 70, or 0.7, 0.8, 0.9, and try to find a combination where you're getting 10 rules. Okay, what will happen? Business will have some good time trying to understand 10 rules rather than 100 rules or 20 or 200 rules. Okay, that is how they found out the customers were purchasing diaper and beer together. Okay, let's make one step progress here. Come here. Let's see what else we have. Here is rules, association rules. Now what is this one we are calling this? You gave the data, you gave your minimum support. This is more of a method. If I say x plus y whole square, you don't ask me how x square, y square, 2x, how you do that. You don't ask me. That's like a formula, guys. Okay, that's a method. Okay, you start with some number, give them a support. For you, you're interested in those patterns which are occurring, 7 out of for every 100 transactions, 7 times these patterns are appearing. These combinations are appearing is where you're starting. So now, what is this one? When you call the function, it gives you some output. You're calling them as frequent item sets. The frequent item sets are now given to another function called association rules. Here are the rules. And now, let's say I come back here. This is generally how we work with. Here are the rules. So, whenever customers are purchasing 36 pencil retro sport, one more time, let's say come back here. Scroll up here. When customers purchase this one, let's see. Wonder why it's taking that much time. Let's go to images. Okay, when customers purchase this retro sport, what are they buying? There again looks like they're going for a red cake stand. This is just one example, guys. So here is cake stand is just what we looked at. They're going for a similar combination, and this is happening 7 out of 100 times. That is antecedent support. Then, if you scroll down a little bit, scroll towards right. So here is the confidence. Confidence is again just a conditional probability. Lift is again 14. Lift is high means these two seem to be going a lot together. For some of them, lift is low. Then leverage and conviction, I will not venture into those things right now. Those are a little too advanced to explain in this right now. But what do we do? This is what data scientists do. What we are doing is we are not only focusing on the data, we are also focusing on code. Okay, it is not completely programmed, not completely data. It is a combination of batting and bowling. It's like cricket is a combination of batting and bowling. There is running. You have cricket. Everybody likes to do batting and bowling, but you also have to stand. There is also fielding. You stand there. What is that? Fielding and running, or we'll call fielding as programming. You're a programmer. You're also going to be focusing on data. What is data? That is data. What is that? For that, in order to do that, you're going to write different kinds of rules. You're going to learn different kinds of functions. Everybody catching the point, guys? It is not that you're going to be a completely programmer. It is not that you're going to be completely focusing on the data. You're going to do a combination. And what is more important is you're not building the UI tools here. You don't necessarily build, hey, I'll build this button here, I'll build this button, that button, this button. That is more of a Java or a .NET like programmer will focus, guys. Data scientist is you're focusing on the data. You're trying to understand the patterns. You're trying to help the business. For you guys might think, whenever customers are purchasing, this, what is this? Pencil stand, they're purchasing cake stand is something simple, you might think. But you go to a business and tell them that will be very useful, very helpful. Without you knowing, they'll be able to understand many things. So if you can find this kind of patterns, can you help me in understanding what customers are buying when they purchase diapers? And suddenly you'll be able to feed the data. And now come back here, guys. Take a look at this. Let's go one step here. So this generates 800 rules. I will see this one here. And I will not go into visualizations. Visualizations are slightly confusing here. But let's say, take a look at this one for simplicity. Give me all the rules where the lift is greater than or equal to 6 and confidence is less than or equal to or greater than or equal to 0.8. So a couple of them, rules is not defined. Let me see where is rules here. Association rules, let's say. Run this one. Association rules is not defined. Oh, my bad. Sorry, guys. I'm executing in a wrong place. So let me, I'm actually, I've been spider. Let's say, oops, more time. Let's come here. Rules is already there. I will go here. And let's take this one. Copy this one. Look at this. So antecedents, consequence. So here is the data frame. We have support, confidence, and low. Things like that. So these are the combinations which are happening. Red retro spot and cake stand is coming up here. Scroll down a little bit. So what is happening is, let's say, take a look at this. We say print red retro spot cake stand. Do a sum. 23 of the cake stands have been sold. What's happening is, if you do this, 385 of the pencil tubes have been purchased. Imagine for a moment business expected if somebody purchased 385 pencil tubes, they should have also purchased more than 300. But that is not happening. Okay, this is like cross-selling. The cross-selling is not happening. This is not a good combination. Maybe they put these two things together as a good discount, a promotional pricing, but this is not happening. What is that? That's an interesting insight. That's a very useful insight. That's a very helpful insight. Maybe they spent a lot of money. They reduce their margins and things like that. There's a lot of business reason. But this is not working out. What should we do? We should change it. Okay, everybody catching the point, guys? Can you give me a quick yes? Okay, now if you're getting that, let's say come back here. If you got that, let's say come back here. Now take a look at this, guys. Everything is same. Basket rules and things. Now the only thing I'm going to change is instead of Australia, I'll take France. I will repeat all the steps from top to bottom. Let's say run up to here. Here is the rules. Let's say here is now run up to here. Data is not different. Oh, sorry. I'm going to copy this one. This is here. Let's give it a moment. Now take a look at this. After it all prints, in France what is happening is the same similar pattern is happening. It is not only in Australia, it is in France also we are observing. When? What is happening? Only when they buy 68, for every 300 pencil tube stands, they're only purchasing 68 cake stands. Okay, what is that? That means something is not right. It's not just in Australia, it's also in France. What about the other countries? Or imagine for a moment, the reverse is happening in France. For some reason, they're purchasing more cake stands and less this one. What do we do? That becomes another interesting thing. So product A is being sold more in Australia. Product B is being sold more in France. What do? You ship all the product A's from Australia to France or vice versa. You can come up with that kind of planning. Everybody catching that point, guys? Here, I'm only looking at one. But you look at, this is what we do as data scientists. And for this, we are touching the code. We are looking at the data. Okay, what is that? That is your motivation to learn a little bit of programming, Python programming and things like that. Okay, and gentlemen, ladies, in real world, you will now go and take this kind of concepts and apply in healthcare data. You will be given the telecom data and you will try to come up and say some interesting rules like this. Everybody catching the point, guys? Quick yes, please. So there are a lot more that we can talk about this and spend some time, but due to our the scope of this thing, I will not be able to discuss more in detail, guys. But hopefully that is giving you an idea, guys. Okay, I'm trying to motivate you why you should learn a little bit of programming, even though you're coming from a different background. Imagine you're a mechanical engineer. Imagine you're a civil engineer. What can you do? You have to take this concept. You take your mechanical engineering data. You take your civil engineering. You'll find some very, very interesting insights coming up. If you're a civil engineer, you have this concrete. You have various attributes of concrete. You can take the data, you plug it into ARM, and it'll tell you some interesting things. You're able to maybe explain the error tolerance of a few components of that you mixed in structural engineering components or mechanical engineering components and things like that. Okay, the concept is same, data is different. What you need to do is learn to drive a car. It's better to learn to drive an ambassador car. If you can drive an ambassador car, you'll be able to drive a BMW and a Benz. So the concept, the algorithm is what you do. What you do, you don't invent, you don't discover how to, you don't invent a new algorithm. You need to know when to use the right algorithm. If you want to use a hammer or a screwdriver, don't use a screwdriver or a hammer. Use a hammer and a screwdriver. Where you need a hammer, use a hammer. What is hammer and screwdriver? The right machine learning algorithm. What is that? That's what data scientists do. Okay, guys, everybody catching the point? Let me open up. Open up a little bit for questions and things like that, guys. I'll give you about 5 to 10 minutes for a few questions, and I'm going to stop the sharing. I'll be for a moment here while you're typing in the questions, and I'll try to upload this one to GitHub. So I come here. Okay, I'm doing it right now, Sri. That's why I stopped the sharing. Yes, I'm going to upload the data and the code in a moment, guys. Okay, because I'm explaining the code while I'm running Hemant, I'm not able to show you the code too much time, but I'm going to put it on the GitHub. You look from there and you take your own time in understanding it. Get internship as a fresher in the field of data science. Aruna, yes, you can definitely try for internships and things like that. Just like any other job, just like a Java or a .NET, you can start as an intern. You can then get some experience and try for a full-time job and things like that, Aruna. That's a short answer. It's not that they don't offer internships, mainly for marketing. Uh, ARM, it's not just necessary for marketing. You can use it in any domain, and that's what you will do in real world. Okay, you need to take different kinds of data in the domain that you're working. You can use it and you try to see if you're able to come up with a reasonable story. It's not that it is only applicable in a specific domain. Opportunities too. So there are again machine learning, deep learning. These are new skills and techniques, guys. Every job will require these skills. So you should try to learn them, and then you try for a job. I'm sure you guys are all, once you complete your BTech or whatever degree you're trying for jobs, add the machine learning, add the Python, add the deep learning, and then try to search for the jobs. You'll get a better response. I cannot assure you a job, but I will assure you'll get a very good response, or you'll get a more positive response. If you want to develop your own ML algorithms, you can do that. It's not that you should not develop, but generally that is, you can take up, generally the PhD guys, all those guys work for years and years, and they come up with different kinds of algorithms. Pratap, it's not a small thing. You have to do a lot of, uh, you know, you have to come up, you have to spend a lot of time and things like that. But yeah, well, you can also take up a PhD if you are interested in going in that line. But I see most of the times people want to get jobs, so I'm answering from that perspective. Yeah, if you have basic Python programming skills, that is enough, guys. You don't have to be a Hussein Bolt to be a Sachin Tendulkar. You don't have to be a very expert Python programmer, and you'll still be able to manage to write a lot of decent code as a data scientist. In PySpark, the packages are similar to Python. Just one thank you, buddy. So if you learn Python, scikit-learn, your PySpark will also be similar. You will use a similar terminology and things like that. Asking about data science internships. Yeah, so again, Aruna, the same answer. You can definitely get data science internships. That's what I'm also answering. And let me come back here. Let's see if I'm able to upload this one. Let's say, what can I do here? And let's say, come back here. Yes. Okay. Committed. So clustering is added, guys, and I'm going to upload a file. Give me one moment while I get back to your questions. Our data sets. Looking at online retail and clustering is small customers. all customers.csv. Online retail.csv. Oh, the smaller file. Okay, I'm having some issue. I think it doesn't allow the more than greater than 25 MB. So I uploaded the clustering and the mall customers, guys. I think I may need to cut short that file and I will upload that. And let's see any other questions here. Start our career with this certificate. Yes, that's a good idea to take up a certification. Yeah, I'm not sharing, guys. I'm just doing some multitasking here. So Sri, you can check the GitHub. I've shared one of them, association rules mining. I'm going to put it in a moment. Let's see where we are. Okay, gentlemen, ladies, I also need to get on to another one. I'll be signing off here for today. Let's continue the journey from tomorrow. And I will try to upload this one in association rules mining in a few minutes because the data file is too big. It's giving me an issue, guys. Otherwise, I'll try to put the link there so that to the actual one and we'll continue from there. For today, I will be stopping it here, guys. And Mansa or our team will be taking the feedback and things like that. Thank you, guys. Signing off for today. Thank you.
Yes, sir. Thank you. Yes, sir. Thank you, sir.
Thank you, buddy.
Yeah, guys, the feedback link is placed in chat box and similar to the in YouTube also posted in description box. Just check it once. For the YouTube, but already posted in description box and as well as chat also. Today feedback link is posted in chat box. Just check it once. And guys, so APSDC is conducting one more program on artificial intelligence through machine learning. So it is in collaboration with Pantech Solutions. So especially this is very useful for the electrical and electronics engineers. So if anyone is interested, just apply here. So this is totally 15 days program. Each day only 1 hour. It starts from 18th onwards. So this is also totally free of cost. So this is the content for the 15 days program. So if anyone is interested, just register on APSSDC.in. Okay. So APSSDC.in. Yeah, once we receive the end of the training only, we will provide all the materials. We already mentioned many times, end of the training. End of the training only, we will provide the materials, including with your certificate. End of the programming, so we will conduct a small assessment. We already mentioned that is the final assessment. Including that assessment, we will provide the end of the certificate, including the materials we will share to you for your register mail address. Okay. Thank you, everyone. So today's session is the 13th day. It is totally 30 days program. Okay. The today is the 13th, 1-3. Yeah, thank you, guys. Yeah, this is totally 30 days program. Today is the 13th day. Totally 30 days program. All the recorded videos is available on your YouTube channel. Is nothing but APSDC YouTube channel. So if you need any information, just look into those videos. The registration link is apssdc.in. Yeah, tomorrow session is there. Registration link is APSDC.in. Today is the 13th day. Remaining 17 days is left. Okay.